So you guys will watch the first bit of the video, but it's fairly straightforward. We're talking about displacement, and now we're looking at velocity. And what it's saying here is, for velocity, I'll rub this bit out so it doesn't confuse us. For velocity, there are a few little definitions that you want to know. A negative velocity means an object is actually moving to the left. A positive velocity means an object is moving to the right. A zero velocity means an object is at rest. So if you do see the word rest in your question, straight away you've got to think that x dot, which is velocity, equals to 0. So at rest means x dot. Initially means time equals 0. Stationary, which also means what? What does stationary mean? X dot. Y dash. Doesn't y dash equal to 0 for stationary points? So stationary also means it's at rest. So rest or stationary is also x dot equals 0, or y dash equals 0 if that's how you're comfortable with it. Again, the big two here are usually these ones that students don't understand, but x dot is the first derivative, and then we'll come back to them and do more questions. Last one that I want to talk about is acceleration. Okay, here we go. A positive acceleration means the acceleration is acting to the right. A negative acceleration means the acceleration is acting to the left. So that means an object is actually speeding up if both the velocity and acceleration have the same sign. It doesn't matter if they're both positive or negative, as long as they're the same sign, it is actually speeding up. Why is it speeding up? Well, think about what we had written for x dot, like let's say less than 0. X dot, which is velocity, is less than 0. That means the object is moving to the left. If the object is already moving to the left, and I'm saying x double dot is less than 0 as well, that means it's accelerating to the left. So it's acting to the left and it's moving to the left, therefore it's pushing it even further. So it's speeding up. And same thing if I did it the other way around. If I went x dot is greater than 0 and x double dot is greater than 0, it is moving to the right. And obviously at the same time, it's pushing forward to the right, pushing, let's say, or acting, the word that they've used, acting to the right, to the right. So that's why it speeds up. Yep, what was your question? Yeah. No. And then obviously other way around, it'll slow down if it was moving to the left, but acceleration was pushing to the right. So what's going to happen? It's still going to move to the left. So be careful. It's not going to move to the right. It's still moving to the left, but it's going to slow it down because it's trying to move to the left, but there's something that's telling you got to come back this way. Right? So just be careful with that. That would not be everyone thinks that changes direction. It doesn't change direction. It just slows down. So the key thing there was an object will be slowing down if they and A have different signs. An object has constant velocity. So if you see the word constant velocity, that just means acceleration equals to 0. So that's a very important word. You're going to see that in exams. Constant velocity. I guess the way to think about it is your school zones. Your school zones have a constant speed of 40 kilometers per hour. You're not accelerating. So acceleration is equal to 0. You're constant at that speed. So constant velocity, that's that. It has constant acceleration. That's it. So those ones are, again, the most important ones. I think it's time for us to do some questions. So let's try this one right here. The displacement from the origin at time, I'll print the booklets for you guys actually that are here. You probably still want to write some notes though, so don't just put that all away. Pages 1 to 4. Print, and then I'll even print this one. until it comes. We'll get started anyways on this. So the displacement x meters from the origin at time t seconds of a particle moving in a straight line is given by x equals t cubed minus 9t squared plus 4. X equals t cubed minus 9t squared plus 4. Simple. Find the particle's initial position. All right, what do we know initially? That time equals 0. So therefore, x equals positive 4. Double I. Find an expression for the velocity. Well, we know velocity is just x dot. X dot is just the first derivative. So 3t squared minus 18t. Easy. Triple I. Find an expression for the acceleration. We know that acceleration is technically your first derivative of v. It's important that you understand that. But it's also the second derivative of x. In other words, differentiate this guy and voila. IV, that's the word we used before. At what times is the particle stationary? What do we know? When is a particle stationary? Y dash equals 0. In this case, it's going to be when x dot equals to 0. Because dash, the first derivative, is the same as x dot. That's first derivative. So x dot equals to 0 for stationary. So in other words, 3t squared, take away 18t equals 0. Factorize your 3t out. You get time equals to 0, time equals to 6. Simple. Going too fast. V. At what times is the acceleration 0? Question mark. So stop. That's one piece of information. Well, when is the acceleration equals to 0? You obviously make acceleration equal to 0. And therefore you'll get time equals to positive 3. Right? Find its velocity and position then. Okay, to find its velocity, you're just going to sub it in. And find its position then as well, you're just going to sub it in. Any questions there? And whatever the answers that gives you. Nothing too interesting. All right, let's do it. Let's do the next one. Let's do question. Let's do question 2. Oh, I won't skip. We've got time. Let's do this properly. This is important. Question 2. Okay. Again, a particle moves along a straight line so that its distance x meters from a fixed point is this. Again, just so you can see it a little bit clearer. 6 log t plus 2 minus 4t. Is the particle ever at rest? Okay. When is the particle at rest? What's that? What's equal to 0? T is not at rest. T is initially. When you see the word initially, it's at rest. No, x equal to 0, so let's write that. T equals to 0, the word is initial, or initially, usually they say. And then you just said x equals to 0. X equals to 0 starts with O. Starts with O, the word. Origin. When x equals to 0, it's about the origin. When is the particle at rest? X dot equals to 0. Rest is the same as stationary. The problem is, you know why you can't say x equals 0? X is displacement. So, for example, let's just say your car was outside. It's at rest, but are you at home? So you might not be at the origin. Your car's still at rest. So you've got to be very careful with that. At rest would be where velocity, your car's just sitting there, it's not moving. So velocity is 0. Does that make sense? So that would be rest. Rest / stationary. Those are two words that you will see, and those two words mean the exact same thing. So is the particle ever at rest? Obviously that means you're going to go and find x dot. So x dot equals, how do we differentiate a log? Derivative of the inside over the inside. So we get 6 on t plus 2 minus 4. Yep, anyone not comfortable with that differentiation there that I've just done? 6 and then on t plus 2 take away 4. Okay. And then obviously for it to be at rest, you're going to make it equal to 0 plus the 4. I think you know what I'm going to do now. Basic equations that I'm sure you all miss. 6 equals 4t plus 8. Bring the 8 over, and you can already see what's going to happen. T equals to -½ which means no. You can't get time as being negative, so therefore the particle is never at rest. Simple. It'll never be equal to 0. Simple. Double. Find the acceleration. Well, you know what you're going to do. X dot is this. Please be careful. X dot, you know we can't differentiate with t's or x's or anything in the denominator. So make sure you bring it up. Don't forget your basics. There it is. That's x dot. So x dot would be -6. Open bracket. T plus 2 to the power of -2. -4 disappears. Find the acceleration when time is 2. You're just going to sub in time is 2. 2 plus 2 is 4. And then again, whatever that gives you, we're not so interested. I'm sure we can all use a calculator by now. So triple I. Move on. What happens to the velocity as time approaches infinity? Now, you will 100% get a question like this in both your trials and your HSC. 100%. There's only 2 styles of questions. So the first style for infinity questions is if it's 1 over, let's say, t. The other infinity question you'll get is e to the -t. So if you see, if I've got 1 over infinity, what's 1 over infinity? 1 divided by infinity. 1 pizza divided by infinite slice. What is e to the -infinity now? Think about it. E, give you exponential function. What happens as it approaches -infinity? Not positive infinity. Say it again. Yeah, it approaches what? It approaches 0. They both approach 0. Here's your infinity graph. Here's your exponential. What happens as e is approaching -infinity? What happens to your y value? It approaches closer and closer to 0. And same thing with your hyperbola. Technically, if you want to think of this as a hyperbola, if I draw a hyperbola, there it is. What happens as you're getting to infinity this way? Your y value is getting closer and closer to 0. So what I'm trying to show you is, for both questions of infinity, the logic is 0. It's going to be 0. You've got to keep that in mind. Cool. So that component is 0. So just keep that in mind. Let's look at what it's saying for this question. It's saying, what happens to the velocity? Okay, so we need to write velocity. Velocity is 6 on t plus 2, take away 4. So what happens to the velocity as time? So as time approaches infinity, what happens to this component here? What's 6 on infinity plus 2? I just said it to you. Don't think about it. No, 0. I just said. But wait, what's infinity plus 2? What's infinity plus 2?
But infinity equals to
Yeah. How big is infinity? Correct. Plus 2. What's a plus 2 going to do to it? Nothing. So it's still infinity. And then what's 6 divided by infinity? Still 0. Now imagine 6 pizzas again. Divide by infinite slices. How much are you going to get? You're going to get nothing. So it doesn't matter. It doesn't matter how large the top is. If you're going to divide it by infinity, even if you say a million divided by infinity, infinity is immensely large. So you're still going to get 0. So what's 6 on infinity? We said 0. So what's 0 take away 4? Negative 4. So what happens to the velocity? The velocity will eventually reach negative 4. So let me write that. Velocity will... Oh, and that's another word that they use, eventually. If you see the word eventually, it actually means time is infinity. So velocity will... Because eventually means... Yeah, so be aware of that. Velocity will eventually be negative 4. Velocity will eventually be negative 4. This component equals 0. Azra, I can't see the chat, but if you've got any questions, just ask us. I'm sure you guys can see the chat. I hope one of you let me know if she messages. But I think it's okay. Okay. Let's do another one, which is distance. Good. Question 3. Just clearing up what you had already. Yeah, okay. So the velocity of a particle is given by this. That's the velocity. Initially, what do we know initially? Yeah, so you got to wrap all that around your head. It's more that stuff. So time equals 0 initially. The particle's at x equals to 2. When is the particle, when? What letter is it asking you to find? I asked you when. T. Is the particle stationary? All right, again, we know for stationary, x dot or v equals 0. So in other words, you're going to start with I. You already have v, they gave it to you. So you're just going to go 2t squared minus 2 equals 0. And then I can just plus 2 divide by 2. And then plus minus 1. But you can't get time being negative 1. So please be careful. Time has to be greater than 0. Therefore, time equals to 1. Double I. Find an expression for the position. Okay, if I'm given velocity, I've got to go up 1. I've got to integrate. Right? You guys must have missed. You guys missed this at the beginning. Do you know the order? Displacement, velocity, acceleration. You know that order. So you know we're going to go up now, obviously, to find position. Okay. So I've got v. If I want to find x, I'm going to integrate 2t squared minus 2, and then of course, if it says t, you got to write dt. If it says, I don't know, you'll only get t because you guys are dealing with time in your course. 2t squared minus 2 dt. Next one, we integrate 2t squared. The integral of 2t squared is 2t cubed on 3 minus 2t plus c. And then the whole point of why they gave you this in the first place, initially, is so that you can find the plus c. So time is 0, and but time is 0, x equals 2, so you get x is 2, time is 0, 0, you get c equals to 2. Therefore, the answer we're looking for is 2t cubed on 3 minus 2t plus 2. Good stuff. Again, when is the acceleration 0? Obviously, you're just going to differentiate now from v. Acceleration equals 4t minus 1. Oh, I saw that as a 2. I just realized in I, 2t squared minus t. Oh, I did it again here, didn't I? Well, problem fixed. Not that it matters, it doesn't make a difference. It actually doesn't make a difference to anything. 4t minus 4, it's just going to be 4t. And when is the acceleration 0? You make this equal to 0 in this case, so that's just time equals 0. Whereas in the other case, it would have been a quarter, whatever. IV. Find the distance traveled in the first 5 seconds. So when you're trying to find distance, what you've got to watch out for is when the particle is at rest. Yes. The reason why you've got to watch out for where it's at rest I'm going to do this. Let me think about it. So if I had to work out the distance in the first 5 seconds, let's just say it started from here and it got to here. If I'm trying to work it out, the problem is, can you see how you're going to have some negative areas and some positive areas? This is the original one. Let's say this is x. This is x and this is time. Because you're going to have some negative ones down here, that's a problem. Because you can't have negative distance. So the way to do distance properly is you're going to integrate your velocity still, right? Because you want to find x. So you're still integrating velocity. But the logic is it's got to be from, let me just make sure I didn't get it wrong as well as I'm talking. Yeah. Or integrating. Nice, I'm differentiating this way. Where was I? So I'm here with my velocity. I need to work out I lost it. Intercept station, I just want to make sure I'm not going to say wrong before we do it. Going down is for integration, going up is for differentiation. So that means intercepts become stationary. Intercepts become stationary. Yep. Stationary becomes point inflection. Stationary becomes a point inflection. Yep. And I just said to find the distance, I'm going to integrate from to where velocity, where it's at rest, where velocity is equal to 0. I wasn't wrong, I choose these components here because they're going to give me my stationary. It's good, I got it. All right, so we're going to, I'm sure that's why they gave us that in the beginning. So to find the distance traveled in the first 5 seconds, to avoid the problem that you're going to have with the whole negative areas, which means you're going to have negative distance. To avoid that, what you do is you're going to do it from 0 to 1 plus from 1 to 5. Now, obviously, if you just left it like this, you're going to still get negatives. It's going to be wrong. Because you know the whole point of why you're doing this, which is to offset the negatives, don't forget there should be an absolute values. And because you don't really care about which one's positive and which one's negative, just keep them both positive, you won't go wrong. So if it's positive, it's always going to be positive. If it's negative, at least it's going to revert back to a positive. And that's the proper way of doing distance. To find the distance traveled, we're going to go from 0 to 1 of the velocity function. 2t squared minus 2 dt plus 2t squared minus 2 dt. If it didn't affect you, it didn't affect you. If it did, at least it's more correct because you've got the absolute values. Does that make sense? So sometimes it might not impact it, and you might be getting it right from going from 0 to 5. But it's not the right way for me to teach it. So I'd rather just say it's going to be from 0 to your rest point, and then from your rest point to your next rest point. Okay, if there was 2 rest points between, like if it was 1 and 3, then I'll have to go from 0 to 1, 1 to 3, then 3 to 5. Now we're going to do it. So my answer for this one is integrating this, which we have done here. 2t cubed minus 2t cubed on 3 minus 2t. So 2t cubed on 3 minus 2t, and then 1, 0. Oops, what am I doing? I can get rid of this and make this into an absolute value instead. Plus 2t cubed minus 2t, 1, 0, absolute value. Sorry, 5, 1. All right, let's go. This time I will plug it into my calculator. And what you probably can see, can you see that first one's going to be negative? We'll double check. Yeah, can you see that? And see, if you didn't write that when you're going from 0 to 5, that would have been negative, but you would have never realized it because you're going from 0 to 5. Okay. All right, so the answer has to be absolute value, and then you're going to sub in 1, so 2 over 3 take away 2, which is 2 over 3 take away 2 should be negative 4 over 3. Subbing in 0 is not going to do nothing, so I'm just going to leave that. Plus, now we're going to sub in 5. Absolute value, sub in 5, 2, 5 cubed minus 10 is 240 minus sub in 1. Sub in 1, 2t cubed on 3. 1, 2, 3. Sub in 1, I get negative 4 over 3, exactly like I did before. But you don't just make that negative 4 over 3 into a positive. Right? You don't make that into an absolute value. It doesn't work like that. It's the whole thing. Done. The answer should be 4 on 3 plus 240 plus 4 on 3. And that's the answer we're looking for, which is 242 and 2/3. If you're curious, I mean, I guess we could have seen what happens with 5. Let's see, if you had done it from 0 to 5, the answer would have been 2t cubed on 3 minus 2t, 0 to 5. You know 0 is not going to do nothing, so you're just going to sub in 5. So 2, 5 cubed on 3 minus 10. 73.33. And you can see now, just from me telling you about the absolute values, the reason why this is so small is only because you had a lot of these large numbers, but then you're going to subtract it, it's going to get you back down to here, whereas it's wrong. You got to watch out for your rest periods. So just be careful. Distance is different to displacement. All right, and then V, find the distance traveled during the 4th second. What does that mean? 4th second. So that would mean find the distance traveled in the 5th second, which we did, and the distance traveled up to the 4th second, and then subtract. Do we get that? If I find it, so it's find the distance traveled just during the 4th during the 4th second. So that means 4, 4.1, 4.2, 4.3, and so on. That's during the 4th second. So I'm saying you would find the distance in the 5th second, which is here, minus the distance of the 4th second. So 4th second is up to the 4th. Does that make sense? When you're subbing 4, you're finding it up to 4. So like 3.99 and then became 4. So to find it during the 4th second, the whole distance, that's actually 4.1, 4.2, 4.3 up to 5. So you're going to find the distance at 5, subtract it at 4, and that should be the distance you've traveled in the 4th second. In the 4th second. Well, no. Oh, that's what you say. No. Well, how could you do that? You mean like go from integral between 5 to 4? Oh, I think so. I think you can get away with it. But you can only get away with it. You can only get away with it because, look, should you do it? Maybe I'm overcomplicating. Maybe I'm thinking of like extension concepts and stuff, which you guys might not need to worry about. So you probably can get away with it. I've just got to put a little but if there was a rest point between 4 to 5. See, there isn't a rest point between 4 to 5, so it's not going to make an impact. I am going to do what you just said. Draw the graph or know where your rest points are. If you know the rest is straight away at t equals to 1, well, that's not going to impact 4 to 5 at all. Good job. Yeah, I'm just going to do that actually. You can take over my position. Come, I'll sit there. I'll be happier. V from 4 to 5. From 4 to 5 during the 4th second. From 4 to 5, and then 2 t squared again minus 2 dt. Again, we know the answer is 2t cubed on 3 minus 2t, and then 5 and 4, sub it in, and you're done. Why don't we need absolute values here? Because you know it's only going to be the negative in the rest area. So this shouldn't have an impact. So 2, and then 2 bracket 5 cubed on 3 minus 10, and then minus open bracket 2 4 cubed on 3 minus 8 close bracket. I got 116, so 30, 38 and 2/3, something like that. So if you want to check it at your own time at home, if you do exactly what we just did above for 4 seconds, what it should have given you is 242 minus 38. Should have given you 204. The distance at 4 seconds should have given you 204. So when you subtract it, it gives you 38. Make sense? Cool. All right. Let's exactly the same thing. I'll leave that one out there so you guys can try it at your own time. We'll do those ones in the other book, but again, I'll leave those ones for you. Have you done motion involving trig functions? Yep, let's do that. So let's do, I'll do question 2. Looks like it's got everything. Let's do question 2. And then we'll move on to the next booklet so you guys can try that at home at least. And come back with more questions. So v equals to 8 cos 2t is the equation of the particle's velocity in meters per second. The particle was initially 3 meters to the right of the origin. It's very good, a very important point here. If I said initially 3 meters to the left of the origin, that means x equals -3. You got to keep that in mind. So even though it says 3 meters, and this also says 3 meters, if this one's saying it's to the right of the origin, it's +3. If it says left of the origin, you have to remember it's -3. I've seen that done a few times in HSC, and a lot of students actually substitute x equals 3 because they just see 3, but you got to remember it says left of the origin, it means x should be negative. Okay, let's do this question. Find the equation for the displacement. To find the displacement, of course, we're going to integrate v. So integral, so I'm going to write x equals integral of 8 cos 2t dt. Hopefully we know that whole SC thing by now. Going up is going to be integration. Pretty sure. Going down is differentiation. All right, so if we're integrating cos, it should be a sine still. So it's going to be 8 sine 2t. Nothing changes, except you have to differentiate the 2t, which is 2, and then we divide by that. Sounds good? Plus 6. Then it does say that initially 3 meters. So again, when time equals 0, x equals 3. Sine 0 is obviously 0. And then x equals to 3. So you'll just get c equals to 3. And you'll end up with your displacement function as 4 sine 2t plus 3. Any questions there? Double I. Find equation for acceleration of the particle. Acceleration, again, you're going to differentiate. Acceleration is just v dot or x double dot, however you're seeing it. So differentiate 8 cos. Derivative of 8 cos is negative sine, so that's going to be negative 16 sine 2t. Derivative of 2t is 2 times it. When does the particle first reach the origin? What do you know? You know that means? Find time. Find time. Right? When? Find time. And what do you know? You know if it's at the origin, so therefore x equals. You all right with that, Alex? Yeah, origin. So x equals 0. All right, we're back to equations. So minus the 3, divide by 4. Don't inverse a negative. Don't, right? Don't inverse a negative. We spoke about that. Remember that? Don't inverse a negative. So it's going to look like this. I'll put it like a little hat so you don't forget. But that's not the answer we want. That's just an answer we want so we can work out our all stations to central. Where is sine negative? You would say here and here. The angle you get, inverse sine, 3 on 4. Now, what you guys got to remember is this is time. Time is not really in degrees. Time is in radians. So if you're writing your answers in degrees, it's fine. It's fine. It's just that last step, you really have to convert it to radians. Cool? Or right at the beginning, you have radians. Now, I think you're more comfortable with degrees, so I'm going to keep things in degrees and just show you what to do right at the end. That's very important that you understand radians. So you can't have time 45. That's 45 degrees. So you got to convert it. Your time is pi on 4, for example. All right, so inverse sine 3/4 is 40, we're going to round it up. We'll just round it up, make it exact. 49 degrees. All right, but that's not our answer we want. We want this answer. 180 plus 49. And 360 minus 49. Which is 311 degrees. And it just says first reach the origin. So I'm not going to do the other ones that I was showing you, I think last week, Steph. You know, we said we've got to add 360s. We're not going to do that now because I only need the first time it happens. But if it was a different question, like what we were doing last week, no, probably have to add 360s. Yeah? So then if I just want the first time, I'm just going to divide by 2. 229 divided by 2 gives me about 114.5 degrees. I can't do that. You got to times it by pi on 180. So the answer we want, pi is actually pi, 3.14. The answer we want is 1.998, which in other words, it's probably when time is equal to 2. 2 what, seconds? Yep, per second. I rounded already here, which I shouldn't have, but it's just for demonstrating it to you guys. Whereas I would have kept this exact in my working out as much as I can. I can write this down in your calculator. It's good to get used to storing the exact answers. Does that all make sense? Double check all the working out. Yeah.
I think
114.5 times pi as pi. Why? Because you can't use 180 degrees. Why is pi not 180 degrees? You're finding what? Why are you finding radians? It's time. Is time in degrees? Time is like 3, you can say 3.14. You can say time is 2 seconds. So the context is very important. If you think of the topic where you did all this, like sectors and areas of sectors and stuff like that, if you're finding the angle in a sector, the angle can be in degrees. But if you're finding area, and you found area as pi, can you say area is 180? Area. Yeah. No. There's no such thing as area as 180 degrees. So what would area be if it was pi? 3.14. You get so the context is important. If I was finding arc length, and you found it to be pi, it's not 180, it's 3.14. All right, yes.
Why did you use
Radians at the beginning?
Nope. For the grade 11? Why did you use 3.5? And why did you use?
Oh, why did I use 311? It just says first. When does the particle first? Yeah, and that's what I meant. Like last week, we added 360 though. You remember? Why didn't I add 360? First. All I care about is first. So the other answers are irrelevant. I'm not going to do more work if I'm not required. But I should have. Like technically, there should be plus 360s. That's the proper way. But for this question, because I only need the first one, I would ignore everything else. IV. When does the particle first come to rest? When will it first come to rest? Well, again, rest is when velocity is equal to 0. Velocity is equal to 0. So again, negative 16, negative 6. No, that's acceleration, isn't it? What was velocity again? Velocity is 8 cos 2t. 8 cos 2t equals 0. Divided by 8 doesn't do nothing. Inverse cos of 0. Shift cos 0 should give you 90. Yep. Oh, there's degrees for now. 90 degrees. And then again, Steph, it's just because it says first comes to rest, I'm not going to do the rest. But in reality, I should have done my all stations to central and found more. T equals to 45 degrees. Alex, it doesn't make sense, right? You can't get T equals 45 degrees. That doesn't make sense. So the answer is either pi on 4, but I want to make sure that it's clear. Pi is not 180, so that's why I'm plugging it in as pi, and the answer we're looking for is 0.79. In 0.79 seconds, the particle will first come to rest. Obviously, you know it's a cos graph, or sine graph. They will be at rest a few times because it just keeps oscillating, right? Up and down, up and down, up and down. So you're going to get positive areas, negative areas, positive areas, negative areas. And that's why this one says now, find the distance traveled during this only period, from 0 to pi on 2. That's 90 degrees. But we know that it comes to rest when? At 45 degrees. So I'm going to do my distance from 0 to 45 plus 45 to 90 in absolute values, and we should be good. So, V, distance. We do it from 0 to pi on 4 plus from pi on 4 to pi on 2 for my velocity function, which is 8 cos 2t. 8 cos 2t dt, 8 cos 2t dt. See you. Done? Easy. Sure. Done. Have a good night. Bye-bye. 8 cos 2 dtt, 8 cos 2 dtt. And then integrate 8 cos, I think we did it up here, didn't we? Negative 16, is that the one? No, that's differentiate. Here it is, 4 sine 2t. Happy days. But 4 sine 2t, let me just make it clear one more time. Alex, absolute values. Where's my absolute values? You're going to sub in pi over 4. What are you going to sub it in as? Just be honest. What's the first? What would you have subbed it in as? You're going to sub in pi on 4. Would you have subbed it as? You got to tell me. What would you have done? Because then that means I need to fix what you would have done. So I need to know what you would have done. So then that way in your exam you don't have to change it. You can just do it the right way. Then that's fine. Make sure your calculator is in degrees. So that's fine, right? As long as your calculator is in degrees, sub in 45 degrees. So don't sub in pi as pi. That's what I'm trying to say. Okay? Why? Because where are you subbing it in now? You're subbing it to sine. Can sine be degrees? Yeah, sine can be in degrees. So the context is important. All right, 4 sine 2t pi over 4 pi over 2. Plug it in. Whatever it gives you. Just keep in mind absolute values, absolute values. Sine, this one's 90. That gives me 4 minus 4 sine 0 should give me 0. So absolute value didn't matter there, which is fine still. This one, 4 sine 180 is 0 minus, we know that at pi on 4 it's 4. So can you see I got negative 4 here, and then absolute value of negative 4 should have been positive 4, so the answer would be 8. If you didn't do that, for those who did 0 to pi on 2, thinking that that's distance, their answers would have looked like this. And then they would have subbed in 4 sine 180, which is 0, minus they would have subbed in 0, give them 0, so they found their distance is 0. I think it's clear by now. When you're trying to find distance, it's different to displacement. Distance, you must take into account where you are at rest. Wherever you're at rest is your stopping point. So we were at rest at pi on 4, stopped, absolute values, and then, okay. Any questions? Check on Azra. She hasn't said nothing. Okay. All right. I guess your turn. Let's start with these booklets. Azra, I'm going to send these across right now as well to you, so you can look through them. I'm just going to get these guys working on these, and